9.7 is about similarity transformations. Now, these transformations are real similar to congruency transformations, except the major difference is that you're going to talk about dilation because you're dealing with similarity, which means they're going to be similar. Angles are going to be the same size or proportional. So what is the image when you apply dilation 1.5 following a reflection of the y-axis? So again, here's your y, here's your x. So you're going to reflect over the y-axis. So when I do that first, E prime goes right there. F prime is 1, 2, 3, 4. 1, 2, 3, 4. F prime is right there. And D prime is 1, 2, 1, 2 right there. So if we go ahead and draw that triangle, that becomes right there. E prime, D prime, F prime. So what are these points? These points are negative 2, 0, negative 1, 4, and D prime is negative 4, 2. So if I'm going to do a dilation 1.5, it's just taking and multiplying each one of those by 1.5. Okay, so what's E double prime? E double prime is going to be negative 1.5 and 6. D double prime is going to be negative 3 and 0. Sorry, I have this mislabeled. This should be D prime. This should be F prime. That's why it didn't make sense. And D double prime is negative 3, 0. And F double prime is going to be negative 6, 3. Because I'm just multiplying each point by 1.5. So if you use a different color, just red for that one, E double prime is negative 1.5, 6. That's up here. Okay, D double prime is negative 3, 0. It's right there. And negative 6, 3. Right there. So you know you're multiplying by over 1, so it's going to get a little bit bigger, and there's going to be your similarity transformation. Okay, problem 2, what is the composition of rigid motions and a dilation that maps RST, which is number 1 right here, to PYZ, which is number 2. So I'm going RST to PYZ. Now when you're looking at it, it looks to me like you got to turn it, right? Now we talked about when you rotate 180 degrees, it's also because these are intersecting lines, the same as double reflection. Now, you're doing a composition of transformations here, so you don't want to go ahead and use like reflect, reflect, and then dilate. So you want to kind of make it nice. So let's go ahead and rotate it. Well, if I rotate it, I need R to match P. How do I do that? Well, if I get R to match P, Y to match S, and Z to match T, I'm just going to go ahead and rotate it about the origin, and it looks like it flips not just left, but completely over. So this is going to be a rotation of 180 degrees about the origin. Okay, that's going to get me right side. Well, now how do I dilate? What do I need to do? Well, it comes down to looking at what the points are. We got T at 3, 1. We got S at 1, 3. And we got R at 1, 1. Well, 180 degree rotation, if we do that first, S prime is going to be negative 1, negative 3. T prime is going to be negative 3, negative 1. And R prime is going to be negative 1, negative 1. So, what matches what? We know we're going from negative 1, because R matches P, and I need to get to negative 2, because P right here is negative 2, negative 2. So how do I get from negative 1 to negative 2, negative 2? Well, what I would do is I would set up my scale factor, take my negative 2, divide by negative 1, and that gives you a scale factor of 2. So I'm going to do that. I'm going to do a dilation of 2 following a rotation of 180 degrees.